couple of things to do and get through today. We're just going to wrap up a couple more examples with the chain rule. And so we're going to find all points on the graph for which f prime of x equals 0 and for which f prime of x does not exist. So first off, we need to interpret where that is and what we should be looking for. So for f prime to equal 0, well, that's pretty straightforward. We just set f prime equal to 0. We just find out where it's 0. But where will f prime not exist? In other words, where will the domain of f prime not exist? Usually we'd have to worry about roots, but since it's a cubed root, that's not going to be the problem. The problem is if we end up with something in the denominator that ends up being what? 0. So if the bottom is 0, then that's a problem. If the top is 0, that's not a problem. So f prime is 0 if the numerator is 0. F prime does not exist if the denominator is equal to 0. Or if we get some other type of domain problem. But let's look at doing this. So go ahead and take a minute and take f prime of x. See what you can do with it. So normally our derivative to the 2/3 would be 2/3 times x squared minus 1 to the subtract 1, negative 1/3. But that's not all, because we also need the last part of the chain rule, times derivative of the inside part. Derivative of x squared minus 1, well, that's going to be 2x minus derivative of 1, 0. So to rewrite that, negative 1/3, that means it goes to the bottom as in a cube root. Here's a 2 times 2 on the top is 4x, and then this 3 on the bottom is still on the bottom. Good so far. So first off, we're looking for where this is 0. Where is this 0? When x is 0, because that's when the top is 0. Then to see where this does not exist, remember we're looking for where the bottom is 0. So where is the bottom 0? What will we put in for x to make the bottom 0? Not 0. If I plug in 0, I get negative 3 to the bottom. 1 or negative 1. X squared minus 1 factors into x plus 1 times x minus 1. Or you can take square root of both sides, and if you take square root of both sides, you should have plus or minus. Whichever way is easier for you to think about. But you want to set that part equal to 0. And that's where you get your answer. So if you want where the derivative is 0, you want to set it equal to 0. Or set, in other words, you want to know where the top is 0. If you want to know where derivative doesn't exist, that's where you want to start to think about the domain of that derivative you just found. So set it equal to 0. Set the bottom equal to 0 is most of the time what that's going to involve. And this is an example of finding places where the function is continuous but not differentiable. because we didn't have a problem with the domain up here when it was just a cube root of a function squared. I can put 1 there. I'd get out 0. But when I took the derivative, this x squared minus 1, this cube root part, ended up on the bottom. And now it can't exist for the derivative. If the derivative doesn't exist, usually that's going to mean, in this case, a slope that doesn't exist. A slope where the bottom is 0 would be a slope that's undefined. So that means we have a vertical tangent line, if we're thinking about the slope of the tangent line. Here, where the derivative is 0, that would be a horizontal tangent line. So they might be asking the question that way too. Find the points where the slope of the tangent line is horizontal. And you'll have to know that that means that we're setting f prime equal to 0. So we are actually looking for the derivative of f of g of x. And we're actually going to use our derivative rule here and do that this is f prime of g, or sorry, we use blue for outside and red for inside. So it was f prime of g of x times g prime of x. That's the more standard way of writing out the chain rule. Outside derivative of the inside function times derivative of the inside part. All right. So let's work with that here. First off, let's find f prime and g prime. So f prime of u. So derivative of this function, u to the 5th plus 1. So that's going to be take the exponent hopping down in front, 5, and then u to the subtract 1, we get 4. G prime of x. This is x to the 1/2, so it's going to be 1/2 x to the negative 1/2, which if I rewrite that, there we go. So we want f prime of g of x. So I want f prime, mixed up my colors, f prime of g of x. What's g of x? G of x is square root of x. Times derivative of the inside part. So g prime of x we just found was 1 over 2 square root of x. So f prime of square root of x, so we're going to take square root of x and plug it into f prime. We're going to take square root of x and plug it into f prime. So that is, f prime is 5 u to the 4th. So instead of u, in comes square root of x. Times derivative of the inside part, 1 over 2 root x. So that's going to equal the square root of x to the 4th. Well, we can square and square again. So square root of x squared is x and then squared. So we have 5 and then x squared over 2 squared of x. That's how we'll leave it. So f prime of, so at 1, at x equals 1, it would be 5 halves. I plug in 1 for x. There you go. So if we wanted to, so I wanted to do this in general, and then show you what the number would look like. You can also do this just with the number. So let's take a look at what that looks like. So at x equals 0, this one's at x equals 0. So that would involve doing f prime of g of 0 times g prime of 0. So the first way to do it is to just do it with the function, find a general derivative, and then plug in 0, which is what we did in the last one. The other way is just to do it with the numbers and plug in 0 from the start. So let's take a look at what that looks like. So first off, f prime of u. Ooh, that's nasty. All right. That is a quotient rule. So low d high, derivative of 2u is 2, minus high d low, derivative of u squared plus 1 is 2u, over square root of what's below. So that equals, here's a 2u squared minus a 4u squared, so negative 2u squared, and then plus 2 over u squared plus 1 squared. Okay, I'll stop there. G prime of x, I can breathe easier. This is much easier. This is just 20x plus 1. But we're not going to deal with, this time, it's going to be much easier not to have to deal with taking this, we'd have to take G and put it into this thing. I don't want to do that, so I'm going to deal with the numbers now. So f prime of G of 0. Let's see. G of 0, as I was saying. G of 0. Oh, that's just 10 times 0 squared plus 0 plus 1. So that's 1. So instead, we want f prime of g of 0. Well, g of 0 was 1 times g prime of 0. That's going to equal f prime of 1. That's going to be negative 2 times 1 squared plus 2 over 1 plus 1 squared. So negative 2 times 1. So that's going to be negative 2 plus 1 is negative 1 on top, and then 4 on the bottom. So I got a 1/4 there. Yes? Good so far? Then times g prime of 0. Well, g prime of 0 is going to be 0 plus 1 is 1. So 1/4. Questions on that? So we can either take this derivative with the chain rule and then plug in our numbers, or we can plug in our numbers earlier and do it that way. But the big thing that I want you to get out of these two problems is being comfortable with that general form of the chain rule, of that f prime of g of x times g prime of x. And what we'll look at next week, we'll actually look at some problems where you'll have a graph of f and g, and you'll have to get the chain rule from the graph, f prime of g of x times g prime of x. And we'll talk about how to do that next week.